Before we get started, are there questions over the homework? So I'm going to start off by saying this lesson today, because we're going to do it today, tomorrow, and Wednesday. I'm going to take 3 days because we're going to go through these. There is a lot with this and not a lot all at the same time. Once we get our head around what's going on and what's happening with these equations, everything will start lining up nicely and we'll see what happened and how it works. But if we miss it and aren't seeing the connections from the equations to the given information and given information back to the equations, it's going to be confusing. So I would highly suggest, especially if something doesn't make sense or what we're doing, ask. Because for these first few problems, I'm going to be restating the same thing multiple times over and over again, just to try to make those connections, make those points clear. Because what we're looking at is the standard equations of a parabola kind of in this vertex form. Now, normally in place of a, it is 1 over 4p. But it does work out that a, the value of a, that number that goes in front of the parentheses, is 1 over 4p. And that value of p is actually equal to 1 over 4a. So it's a nice way to be able to go from one to the other. Now, for both of these equations here, the vertex is the point h comma k. Vertex is h comma k. It's always going to be that, especially with these parabolas. Now, when we look at the equation y equals a times x minus h squared plus k, I'm going to write it here, vertex is the point h comma k. Our focus is the point h comma k plus p. The directrix, y equals k minus p, and it works out that the distance from the vertex to the focus and the distance from the vertex to the directrix is actually the same. The directrix equation is perpendicular to the axis of symmetry. And our axis of symmetry for our y equals x minus h. So we have these here. Now our new equation that we have is x equals a times y minus k squared plus h. So this equation is a parabola, but it opens to the left or to the right. It's not a function because it does not pass the vertical line test, but we still have an equation for it. Now the vertex is still the point h comma k. That's just the vertex. Our focus is now the point h plus p comma k. The directrix is x equals h minus p. And when I'm looking at the equation and the information given to us, especially when they give us the vertex and focus, I'm trying to see what is changing from the vertex to the focus. Because for this one here, x equals, the vertex is still the point h comma k. Our focus is h plus p comma k. The x value from vertex to focus is changing. We're adding something to it. It could go up, it could go down, but the vertex to the focus, the number that we have at the vertex is not going to be the same number as the focus because we're adding something to it. If we see the vertex's y value is k, the focus's y value is also k. It's not changing. So from vertex to focus, one of the two values, either the first value, the x value, or the y value is going to change from vertex to focus. If x value changes from the vertex to the focus, it's x equals. As we see here, the y value changes for y equals. We're going to k plus p. If the y value changes from the vertex to the focus, it's going to be y equals. So that's the main difference between these two, how we can distinguish one from the other, especially when we're given the vertex and focus. The directrix is kind of nice because the directrix for y equals is y equals k minus p. Y equals a number. If they tell us the directrix is y equals, doesn't matter what the number is, y equals. It's going to be the y equals equation. If they tell us the directrix is x equals a number, it's the x equals equation. We're trying to match up what the information they gave us to these general forms to find the values of h, k, p, but we need p to find a. Because we really need a, h, and k to get the equation. Now, when we look at this here, they gave us the vertex in focus, and especially on the homework and on the test, I will specifically say what the vertex in focus is. The big way we can tell the difference, vertex is going to be the smallest or lowest point on the graph. It's going to be on it. Focus is always inside the parabola. Directrix is going to be on the outside of where it opens and perpendicular to the axis of symmetry. So we look at this here. The vertex is given to us as an x value of 6 and a y value of 2. X value of 6, y value of 2. And in the general form for this here, the vertex is the point h comma k. So immediately we know h and k. So the really only thing we need to find at this point is the value of p, because if I can find p, we can find a, we will have the equation. But we also need to figure out which equation we're going to be using, because there's two. We have x equals a times y minus k squared plus h, and y equals a times x minus h squared plus k. We have two equations. And really being able to determine which of these two equations is going to be helpful. And to be able to do that, we need to know which focus we're using, because the focus is going to tell us which one. Because the focus for our y equals, I'll write it underneath here because I'm not expecting you to memorize this. I would especially have this out when you're doing the homework, or especially have this written down when you're doing the test, because y equals focus is h comma k plus p. And our x equals the focus is h plus p comma k. These are the two general forms for each one of these equations, and we need to figure out which one we have. Because for y equals, we're going from the vertex h comma k to either h comma k plus p or h plus p comma k. We need to determine which one's changing from the vertex to the focus. Is it the first value or the second? Did the h's stay the same or did the k's stay the same? Because our focus point here, the x value is 10, the y value is 2. So we can come at it two directions. Which one's changed or which one stayed the same? Which one changed? The first value or the second? The first value changed because it went from 6 to 10. The second went from 2 to 2. So we need to look and see which one do we have a change? Which one are we adding some value to? Are we adding a value to h or k? H, because we're going from 6 to 10. So the corresponding form, the general form, has to be h plus p comma k. Questions on how we line that up? So you can look at it as either which one changed. So here, h, the first value went from 6 to 10, so we have to have that h plus p comma k. Or we can look at which one didn't change. In the vertex, we have k is 2. In the focus, the k value is still 2. It's still 2 in that spot. So the only one that still had k for the vertex and k for the focus was our h plus p comma k, so it has to be that one. If the k value changed and it was still h, we still had 6 for the vertex, or 6 is the x value of the focus. The first value of that focus was 6. We're going to use h comma k plus p because we're not adding a value to h. So all that's told us is that y equals is not the equation for this here, because its focus, h comma k plus p, does not line up with the focus that we have here. That value is not changing. Questions on this here? Okay. Because again, getting this and seeing how this works is crucial for this here. Because now we do have the value of hk. Still need to find p, and we need to find a. Well, the value of h is 6. The value of k is 2. We don't know what the value of p is yet, but I do know that what? H plus p is 10. So whatever p is, when we add it to h, we should get 10, because h plus p, the part of the focus, is 10. But what's our value of h? So we're saying 6 plus whatever p is should give us 10. Well, I can subtract 6 from both sides, telling me that p is 4. What am I missing? I'm just missing the value of a, yes? But a is equal to what? 1 over 4 p. So to find a, I take its equation, a equals 1 over 4p, and I'm going to plug the value of p in for p, so 4 in for p. 4 times 4 is, so a is 1/16. Now for our equation, we really just need a, h, and k. But in order to find a, we have to have p. So under this equation, I'm going to rewrite it out. X is equal to a times x here, y minus k squared plus h. So let's plug in what we know. What's the value of a? So x equals 1/16, parentheses, y minus, what is our k value? 2 squared, plus our h value is 6. We don't have any double negatives we have to take care of, because a negative and negative turn a positive, we would fix that. We don't have plus and negative like with our h on the outside. That is the equation. Questions on this here? So the big thing with this is finding these values of h, k, p, and a, plug them back into their corresponding spots, and we get the equation. Same thing is true if we went the other direction. If we're finding the vertex axis of symmetry focus directions, we're finding these 4 values and plugging them back in their spots and simplifying where needed. But the real tricky thing with this is figuring out which of the 2 equations we have based off the focus and vertex. Now, if we're given the graph, it's kind of nice. X equals is going to open to the left or right. That's just x equals. Y equals up or down. Now, if you also notice with this here, with the parabolas that we've dealt with so far, h was inside the parentheses. K was outside. But in those forms, when h was inside, x was also inside those parentheses. X and h will go together. Y and k will go together. Y is outside the parentheses, k is outside the parentheses. Y is inside, k is inside. Now you can remember that to try to keep it straight, or have the general form sitting right there to look back at and match it back up. Questions on this here? Be ready for the next one. Now they gave us the vertex, but they didn't directly label it or the focus. And again, we're going by 2's. Now the vertex is the point -2, 4. -2, 4. The focus is going to be the point what? 2, 4. Now the nice thing is no matter which equation we get or using, I still need to find h, k, p, and a. Those are the 4 I have to find, no matter which equation we have. Now, the nice thing with this one here is they gave us the graph. We see that it is opening to the right, yes? Which tells us it's going to have to be the x-equal equation. But let's ignore it. Let's say that they just gave us the vertex and the point. We're looking at what's changing, or we can say what's staying the same. I see from the vertex to the focus, vertex is negative 2, 4. Focus is 2, 4. The x value, that first value, is going from negative 2 to 4. It's going from h to h plus p. We're adding some value. We're adding something to it. Because again, the vertex is still always going to be the point h comma k, no matter how it opens. H comma k is the vertex. And if we looked at it, say, what didn't change, well, looking at this new point, well, the k value is still 4. It went from 4 to 4. We didn't add anything. We didn't take anything away from it. So it's still the value of 4. So k is still 4. The y value is still just k, which means the x value has to be h plus p. It's the one that's having the change. It's going from 2 to negative 2. So that tells us that the equation has to be our x is equal to a times y minus k squared plus h. H is negative 2. K is 4. If I want to find P, well, I know that H plus P is what? 2. I know the value of H is negative 2. And we're going to what? Add 2 to both sides, telling us P is equal to 4. Well, we kind of know what A is at this point, not because we intuitively know it. It's just that P was this value on the last problem, so it kind of tells us what it is. But if we didn't, A is still equal to 1 over 4 P. We'll plug 4 in for P. It tells us A is 1 over 16. Questions on how we found H, K, P, and A? I think y'all are starting to see how this is a lot and not a lot at the same time, because once we see how this works and how they all work together, it makes some sense on how we're doing this. Now all we've got to do is plug this back in. X is equal to A is our 1/16 times Y minus K squared plus negative 2, or we can just say minus 2. And we have our equation. Questions on this here? Questions on anything we've done so far? Let's look at the next one. Now, they didn't put the focus on this here. That's because I made this one with the vertex in focus and gave us a graph for it. Now, as we can see here, the vertex, or the parabola itself, is opening up, which is meaning it's going to be our y equals. But if we look from the vertex to the focus here, we can again do it in one of two ways. What's changing? Well, the k value is going from 0 to 0.25. We don't have the same k value from the vertex to the focus. So there's being something added. or something taken away from it. There is a value of P being put there. If we look at the H, because the H value, the first value of the vertex is 1, the first value of the focus is still 1. So for us here, our vertex is still the point HK. And we can see that the focus is the point H comma K plus P. Now the interesting thing with this, and again, we didn't state this on the previous problems, but if we looked at this here, the value of H is 1. The value of K is 0. We don't know what P is yet. It's going to be not too bad to find it, but we can find that. But just with what we're given with the vertex 1 and 0, the only thing we're missing is A, yes? The three things we need for the equation is A, H, and K. I have 2/3 of the equation already. Now to find P, P is interesting for this one, because we're saying that H plus P, not H plus P, sorry, K plus P, is equal to what? 0.25, yes? What's the value of K? So we're saying 0 plus whatever P is equal to 0.25, yes? What's 0 plus P? 0 plus P is just P, isn't it? Because 0 plus P, we didn't add anything to P, it's just P, so P is 0.25. Now, it's really interesting when we start trying to find A. Nope, let's keep the forms the same. Jumping ahead. Because A is equal to 1 over 4P, or 1 over 4 times 0.25. Now, at this point, again, we can plug this in the calculator and let it do it for us. We don't have to do this by hand. Now, what is 4 times 0.25? 1. 4 quarters in a dollar, that's going to be 1. 1 divided by 1 is, so A is questions on how we found A, H, and K, or how we plugged it in. And if you're wondering, yes, we can write this equation a little bit simpler. And what I mean by that is, in front here, our multiplication of 1. It does not have to be written, because if there's not a number in front of the parenthesis, a number written is understood to be a multiplication of 1. Multiplication of 1 is understood. Our plus 0 is understood. We don't have to put plus 0. These are the same equation. You don't have to write y equals 1 times x minus 1 squared plus 0. We can just say y equals x minus 1 squared. That is the same equation. Questions on this here? Because the bigger takeaway with this is not so much the specific numbers or how it's written. What is changing? How do we connect the two back together? Because if we understand more of how we connect it more than just what the numbers are, is it positive, is it negative? Now, what's changing from vertex to focus? That tells us what the equation we have. We find those values for H, K, P, and A. Plug them into the equation, we have our equation, we're done. It's more focused on the general form, not the specific cases. Questions on this here? Are you ready for the next one? Now this one here, there was questions earlier today. Which one's the vertex? Which one's the focus? Well, the vertex is going to be the point on the parabola. Focus will always be inside the parabola. The directrix is going to be below the parabola, whichever way it's opening. Since it's opening up, the equation, the line underneath it would be the directrix if we had it listed. Now the big giveaway, which two of the equation we have, the graph tells us it's opening up, so it has to be y equals. But if we look at the general forms, vertex is the point HK. Our focus, the first value for the vertex is 4. The first value of the focus is also 4. They're both positive 4. That value of H did not change from the vertex to the focus. So the first value of the focus in the general form is just going to be H. We didn't add anything. We didn't take anything away from it. We didn't add some value of P, be it positive or negative. However, K starts out as 2, and in the focus it's 11.4. Start adding something to it, and that value of P could be negative. We could be subtracting an amount and adding a negative amount to it. It's not so much did it go up, but did it change? So that also tells us that our general form is y equals a times x minus h squared plus k. HK, P, and A. H is 4. K is 2. So y equals x minus h squared plus k. And one of the places where most students will make a mistake is putting the h and k in the wrong spot. And again, when I look at these here and I do these problems, I still make sure I have those general forms right there next to me so I don't flip them. It's easy to flip. Now our value of P. We know that K plus P has to equal 11/4. That's just what it tells us there. And the value of K is 2. So 2 plus whatever P is going to be 11/4. To get P by itself, we would subtract 2. Now, if you want to do that by hand, that's perfectly fine. But we can come over here and say 11/4 minus 2 is 3/4. From here, we can find our A value. A is equal to 1/4P. That'd be 1/4 times 3/4. Which will tell us A is 1/3. I will tell you this, the value of A is not always going to be a fraction. It's just worked out that it's been a fraction these times. Because A can be a whole number. There's nothing stopping it from being it that way. A could be negative. Because in the previous one we had A as 1. So again, I would not get stuck on A having to be a fraction or H and K having to be positive. It's again finding those values, lining them up with what we're given. and plugging them into the equation. So we feeling good with this here. Because again, I find this to be one of the trickier parts of chapter 2 is figuring these pieces out and putting them back together. Now from the starting information and what we'll be dealing with, we'll deal with one that's a little bit trickier than focused vertex. That's vertex in direxics. And we have to do a little more with that, but direxics and vertex is kind of nice. Because direxics, and we can look back at the general form, comes in one of two forms. X equals or y equals. Y equals k minus p. Well, k minus p is just a number. Just a number. So y equals a number or x equals a number. If it's y equals, it's the y equals equation. If it's x equals, it's the x equals equation. It's one or the other. Which is kind of nice because we look at the direxics, it tells us y equals negative 27/2. It immediately tells us which equation it is. This has to be our y equals. It's nice in that it's immediate. We're not looking at what's changing, or on the other side of it, what's staying the same from focus to vertex. We're not having to see what changes, what stays the same. It immediately tells us. Vertex's general form is still h comma k. Direxics, y is equal to k minus p. So we do have to, there's going to be a sign change with minus p. But again, that's going to be taken care of when we solve. When we solve for the value of p. Now we are given different starting information, so we have this tendency to think that this has to be a different setup, a different method, a different way to do this. But we're still trying to find hk, and then we need to find p to find a. We need to find the values of hk, p, and a. We find those, we plug them back in. Vertex gave us the value of h and k. Vertex is the point h comma k, so this here is the point negative, or 5, negative 1. 5 for h, negative 1 for k. Now to find p, the general equation for the direxics, y equals k minus p. They told us y equals negative 27/2. Therefore, k minus p has to equal negative 27/2. We know k is negative 1. So the first thing we can do is add negative 1 to both sides. Negative 27/2 plus 1 is negative 25/2. But we're told that negative p is equal to negative 25/2. We don't want to know what the value of negative p is. We want to know what the value of p is. So what we can do is divide both sides by negative 1. Well, negative p divided by negative 1 is, lo and behold, positive p. Negative 25/2 divided by negative 1 is positive 25/2. A equals 1/4p. Plug in p, 25/2, into this here. Questions on how we found P or A? We feel good with this here. Yes? We're good? And the last thing we have to do is plug it back in. Because we replace A with 1 over 50, we place H with 5, and we replace K with -1. We could say plus -1. I think it's easier just to write -1. And we have our equation. Questions on this here? Question on anything we've done so far? This will be the last one we do today. I have a feeling this, y'all will be the class that got the farthest today. Really the second section of Algebra 2, but last hour stopped at the last one. Now we've only done one with directic so far. We're going back to focus. What value didn't change? Are H or K? H stayed the same, so the focus has to be the point H, comma, K plus P, because H stayed the same, so that vertex's first value has to just be H. Or we could say that the value of K changed, so our focus has to be K plus P. Which means if we look back at the general form, H comma K plus P is our y equals equation. So it tells us that the general form for this has to be y equals A times x minus h squared plus K. H, K, P, A. H is what? -1. K is almost 4. But K plus P is indeed 2. Now, if we wanted to plug in H and K, we could. We could say y is equal to whatever A is times x minus -1 squared plus 4. But we don't normally write minus -1. We just say that this is plus 1. Let's find P. Well, K we said is 4. So 4 plus P is equal to 2. We would subtract 4. 2 minus 4 is -2. As I said, P does not have to be a positive value here. It's negative. Last thing we need to find is the value of A. A is equal to 1 over 4P. We have 1 over 4 times -2. Which tells us A is -1/8. That's it. Questions on this here? And I think you're starting to see that if we don't see how each of these pieces connect together, we can get very lost very quickly. But as long as we're focused on the different parts, the H, K, P, and A, we can get from the equation to the given information, vertex, focus, axis symmetry, directs us back to the equation. We can get from one to the other as long as we know these 4 values.